This is the homework for 459 and 460. In problem 459, you use what you know about M and B to graph each rule without making a table. Well, for the equation y equals mx plus b, the m represents the growth. The b represents the initial value, the y-intercept. So in the equation y equals 2x minus 3, this is our starting point on the y-axis, our y-intercept. So we start at the origin and we go to -3, -1, -2, -3. And we have a growth of 2. 2 can also be written as an improper fraction as 2 over 1. Up 2 on the y, 1 on the x. Up 2 on the y, 1 on the x. Up 2 on the y, +1 on the x. You could also do -2 on the y and -1 on the x, because -2 divided by -1 is also +2. For problem B, y equals -2x plus 5. Here's our y-intercept, our initial value, +5, +1, +2, +3, +4, +5. Now you see this has a -2, so it's a negative growth rate. So -2 could be written as -2 over 1. And you see that here. -2 on the y, +1 on the x. -2 on the y, +1 on the x. The other way -2 can be written as +2 on the y, 1, 2, and -1 on the x. Either way, you get a -2. +2 divided by -1 is -2, and -2 divided by +1 is a -2. And you see that this line is sloping to the left towards the negative x values. And you see that negative there? It's telling you that the rate of change is going to be negative. But in problem A, you have a +2, and you can see that it's sloping towards the positive x's. For 459C, the equation is y equals 3x. Well, we've been dealing with y equals mx plus b. And remember, the m is the rate of change. B is your initial value, but there is no b value here. So I represented it with +0, because adding 0 to the equation doesn't change the value of y. So our initial value is 0. Our y-intercept is 0 at the origin. And our growth rate is 3 over 1. Rise 3 on the y-axis over 1 on the x-axis. 3 divided by 1 is just 3. And I can continue that because its growth rate is constant. 1, 2, 3 on the y, +1 on the x. And remember, you could also go down -3, 1, 2, 3, and a -1, because -3 divided by -1 is still +3. In problem D, y equals 1/2 x plus 1. Our growth rate is 1/2, and our initial value, our y-intercept, is 1. So on the y-axis, I go to +1, and then our growth rate, y over x, 1 on the x, 1 on the y, 2 on the x. 1 on the y, 2 on the x, or negative 1 on the y, negative 2 on the x. Remember, a negative divided by a negative is a positive. In problem 460, you need to examine the graph which displays 3 patterns. Part A asks you, what do you know about figure 0 for each of the 3 patterns? The 3 patterns are A, B, and C. For figure 0, you can see that pattern A and pattern C both start with 0 tiles. For pattern B, in figure 0, you can see that it starts with 30 tiles. In part B, which pattern changes most quickly and how quickly does it change? Well, pattern C, you can see that it's the steepest. It's growing at 10 tiles per figure number. A is only growing approximately 3 tiles per figure number. So you can see pattern C is growing much quicker. And pattern B is decreasing. It's losing tiles, and it's losing, looks like 5 tiles per figure number. So pattern C has the quickest growth rate. In part C, which figure number has the same number of tile patterns in B and C? Well, here's pattern B, here's pattern C, and where they intersect, at figure 2, they both have 20 tiles. That's their point of intersection. That's where they're the same. In D, you need to write a rule for pattern B. Here's pattern B. And I talked about earlier how it's decreasing. It's losing tiles for each figure number. And we have the starting point, the initial value, the y-intercept, is a positive 30. And its growth rate, it's decreasing, so we're taking away tiles, so that would be a negative, and we're taking away 5 tiles for every pattern. 5 more tiles, and you can see 30, this would be 25 because here's 20, so 30 to 25, that's 5 tiles for every figure number. 5 more tiles for each figure number. And the equation would be y equals negative 5x plus 30.